Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Ratios Are Our Friends, and they are our friends. And it's by the Bard. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each row, column, and box without repetition. We have non-consecutive, where digits in orthogonally adjacent cells may not be consecutive. And what is an orthogonally adjacent cell? It means cells that share an edge. So these are two orthogonally adjacent cells, these are two orthogonally adjacent cells, etc., etc. So if you had a 6 here, these digits could not be 5 or 7 because they share an edge with the 6 and they cannot be consecutive because of the non-consecutive rule set. And that's an example of how non-consecutive works. We also have ratios, where digits separated by a black dot must be in a 2-to-1 ratio, and all black dots are given. So therefore, if this were a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio that's between them. And in addition, we know the rest of the digits that share an edge, or rest of the cells that share an edge with the 4, cannot be 2 and 8 because all we have are given that all black dots are given. So if we were to try to have a 1-to-2 ratio here between the 4 and say a 2, the problem is there is no black dot there. And if we were to have if there were to be a 1-to-2 ratio between two digits, we have to be given that black dot because it says all black dots are given. So you have a lot of information based off of that. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. Because of the non-consecutive rule set, 1 and 2 can never be in a 1-to-2 ratio in this puzzle. Next to the black Kropke dot, I should say. And these are black Kropke dots, because that's another name for saying them. Next to the black dot, I should say, I guess, since we're using just that construction. Therefore, these digits next to these black dots can only be from 2, 3, 4, 6, and 8. So we will fill that way. So these are 2, 3, 4, 6, and 8 in some situation. Interesting. Okay, we have a set of 5 digits. That's what I was hoping for. So we have a set of 5 digits which require, or 5 cells which require the digits 2, 3, 4, 6, and 8. That means the remaining digits in that column are 1, 5, 7, and 9. Okay. Does that help us any? I'm not really sure if it does. Well, we know, okay, so we know all of these digits are unique. One of them is going to be 4 with 3 or 4 with 2 or 8, and the other pair is going to have to be 3 and 6 in column 7. So this cannot be 4 here, and it cannot be 3 or 6. So we know this is 2 or 8 here. And 2 or 8 is only in a 1-to-2 ratio with 4. So this can't be, this is 4 here. This cannot be 4 here. So this has to be then 3 and 6 as a 1 to 2 ratio. So there's no 4 here, no 3 or 6 possible. It's 2 or 8, which is in a 1 to 2 ratio with 4 only. So this is 4. This cannot be 3 and 6 in a 1 to 2 ratio. So this must be 4 with a 1 to 2 ratio with 2 or 8 here. And this can't be 4, so this is 4. There is no 2, 4, 8 here. This can't be 4 or 4 here. So this is 3, 6 as a pair, which... How did I get that? That's weird. Okay, so this is not 4 or 3 or 6. It's 2 or 8. This can't be 4, so this has to be a 3, 6 pair, which eliminates 3 and 6 in the rest of the box. And it can't be 4, so it's 2 and 8, which is in a 1 to 2 ratio with 4. So therefore, this is 4. This can't be 4 with a 1 to 2 ratio with 2 and 8. So it has to be 3 and 6, which means this can't be 3 and 6. 4 can't be here. It can't be 3 and 6 because of the 3, 6 pair in the column. So it's 2 and 8 again, which leaves this as a 4. So no 4 here. This cannot be then 2 and 8 with it. It's 3 and 6. No 4 here, no 4 here. This therefore must be a 3, 6 pair, which eliminates 3 and 6 in the rest of the column. So this is 4 with 2 and 8, but this can't be 4 because of 4 in the row. So this has to be a 4 here, which must be in a 1 to 2 ratio with 2 and 8. This can't be 4. This can't be 3 and 6 as a pair. So we need one of these to be 4. If this were 3, this can't be 3 and 6 because that's only in a 1 to 2 ratio with another 3 or 6. So 2 and 8 must be in a 1 to 2 ratio with 4 here. So this cannot be 4 there. Actually, pretty cool. This can't be 4. This can't be 4 here. So where's the 4 in this box? It must, or in this ratio, it must be here. This cannot be 4. So this is 3, 6 as a pair here. Okay. Very cool, actually. So let's start coloring things, I guess. We'll make this blue 3, 6 and orange 3, 6. That leaves that as blue 3, 6, orange. So we need an orange 3, 6 somewhere here. It cannot be in these cells. So it has to be here. This is orange 3, 6 in row 6. We need a blue 3, 6 in row 4. And it cannot be any of these cells, so it must be here. We'll make this yellow and pink then. We don't know which one's which. That leaves that as yellow, this as pink. That means pink in row 9 cannot be any of these. Can't be here, can't be here, so it must be here. So that's pink there. This is yellow there. We have a 3, 6, 3, 6 pair here. That means this can't be 3 or 6, which means one of these is 3 and 6. One of these is 3 and 6 there. Because there's no other place for it, because they are limited by this area, this 3, 6 pair here, and this 3, 6 pair here. And they can't be here because of the 3, 6 pair in the row. So this must be a 3, 6 pair there. Interesting. Do we have all the 4s available? We have 8 4s. We know where the last 4 has to be. It has to be here. Do we have 4 next to one of these 3 and 6s? Yes, we have it here. So this cannot be 3 because no orthogonally adjacent cells, which means cells that share an edge, may be consecutive. So this is 6, that's 3. 6 eliminates 6 here, so that's 3 and 6 there. 3 eliminates 3 here, so that's 6 and 3 there. Do we have any 4s surrounding, connecting to these? The answer is no. This can't be 5 because that's consecutive with 4. Cannot be 7 because it's consecutive with 6. So we're guaranteed, well, this is 2 and 8. So one of these two digits is going to be an 8. which 7 and 9 cannot be next to, and 1 cannot be next to. 1 can't be next to the 2, 7 and 9 cannot be next to the 8, and this is a 2-8 pair. So this must be then 5, which means 5 cannot be here. 7 has to be one of these two. Okay. This is 3, 6 as a pair. Remaining digits in the lower right-hand box are 1, 7, 9. This is guaranteed to be 3 or 6. So 7 would have to be next to a 6 here, so that cannot be 7. So we know 7 is one of these two digits here. We have a 3, 6, 2, 8 pair here. Remaining digits in row 7 then cannot be 3, 6, 2, 8. It's 1, 5, 7, 9. Okay. 5 cannot be next to the 4. These two digits have... Okay, so pink and yellow don't help too much either. So let's just clear the... this has to be a 3, 6 pair, so let's do that. That's important, though. So this is 3 and 6. That's 3 and 6. Remaining digits in this central box, or this right central box, are 1, 5, 7, 9. 5 again cannot be next to a 6, and it's guaranteed to be next to a 6 if it's here, so this must be 5 here. This has to be 1, 7, and 9. 7 again cannot be there. Remaining digits in column 9. We have a 1, 7, 9 triplet. We have a 3, 6 pair. So that leaves 2, 5, and 8 here. So we have 2, 5, and 8 here. This has to be 1, 7, and 9 remaining in this upper right-hand box. And 7 cannot be next to a 6. So therefore, where's 7 in this box? It has to be there. 7 cannot be next to 8, so this cannot be 8 here. 3 can't be next to 2, so this cannot be 2 in a 1 to 2 ratio. It's 8. 3 can't be next to 2, that's 8. Which means this can't be 8 here. So where is the 8 in the box? It has to be here. So this is 8. Remaining digits in row 1. We have 1, 2, 5, and 9. And this can't be 2 or 5. 2 is consecutive with 3, 5 is consecutive with 4. This can't be 5 because it's consecutive with 4 and 6. Can't be 9, it's consecutive with 8. Okay. Remaining digits in rows 2 and 3, we have 1, 2, 5, 7, 9. 7 and 9 cannot be next to 8, so no 7, 9 here, no 7, 9 here. 4 cannot be next to 5. 2 cannot be next to 3. 5 cannot be next to 6. So where is 5 in this upper left-hand box? Cannot be sharing an edge with the 4 or 6, so it has to be here. So that's 5, which makes that 2, which makes that 5. There's no more 5 there. 5 cannot be sharing an edge with a 6, so where's 5 in row 3? It must be here. So that's 5, which eliminates 5 in the rest of the column. 6 cannot be next to 7. So we have a 1, 2, 9 triplet here, which eliminates 1, 2, and 9 in the rest of the row. So no 1 or 9 here. It's 7. That means this can't be 7 there. Where is 7 in this upper right central box? It must be here. Okay. 7's one of those two digits. 7 cannot be here because of 7 in the column. We have a 179 triplet now in row 7, which eliminates 179 in the rest of the row. So this can't be 1, 7, or 9. It's 5. Okay. Remaining digits in row 5, we have 1, 2, 7, 8, 9 as possibilities. This can't be 7 because of 7 in the column. That's all we really have there. Remaining digits in column 6. We have 1, 2, 7, 9. Okay. Okay, remaining digits in column 1. We have 1, 2, 7, 8, 9 again. We have a 1, 9 pair in row 2, which eliminates 1 and 9 in the rest of the row. So this can't be 1, it's 2, which means this can't be 2. We have a 1, 9 pair. 2 eliminates 2 here, so that's 1, 9 pair in row 3 also, so this can't be 1, that's 2. Okay. Remaining digits in column 3. We have 1, 7, and 9 available. And this can't be 1. It shares an edge with the 2. So one of these is going to have to be a 1, which means this can't be 1 here. This must be 9. No 9 here. It's 1, 7 as a pair. This can't then be 1, 7 or 9. It's 2, 8 as a pair, which eliminates 2, 8 in the rest of the column. 1, 7 eliminates 7 there, so that's 9. This can no longer be 9. It's 1, 7 as a pair, which eliminates 1, 7 in the rest of the column there. So this can't be 1. It's 9, which makes this 1, which makes that 9, which makes that 1, which makes that 9, which makes that 1. No 9 here. It's 1, 7 as a pair, which eliminates 1, 7 in the rest of the box. This can't be 1. It's 9. That means this can't be 9 here. No 9 here. It's 1, 7 as a pair, which again eliminates 1 and 7 in the rest of the box. So this can't be 1. It's 9. So no 9 here. 9 eliminates 9 from being there also. 2 eliminates 2 from this rest of the column, so this is a 1, 7 pair, which eliminates 1 and 7 in the rest of the column. So this is 9. That eliminates 9 in the rest of the box. Okay. Remaining digits of column. Where is 5 in the central box? It has to be there, which means 5 cannot appear in the rest of this row. Where is 5 then in this left central box? It can only be here. So this is 5, which makes this 2 and 8. We have a 2, 8 pair and a 3, 6 pair here. That leaves this as 1, 5, and 7. This can't be 1 or 7 because of 1 and 7 in the column. So that must be 5. There's no 1 here. It's 2, 8 as a pair, which eliminates 2 and 8 in the rest of the box. So this can't be 5. This can't be 5. This is 1 and 7. Remaining digit in column 5 has to be a 9. And we need a 5 somewhere in column 4. It cannot be here because of 5 in the row. So it has to be here. So that's 5. This is 2 or 8 here remaining. So now we need to probably start coloring a little bit. 9 means this can't be 8 because they share an edge, so that's 2, that's 8. Which means this can't be 8, that's 2, that's 8. Which means this can't be 8, that's 2, that's 8. 2 cannot be consecutive with 3 or share an edge with a 3, so that's 6 and 3, which makes this 6 and 3, which makes that 6 and 3. 1 cannot share an edge with a 2, so this is 7 and 1. 7 eliminates 7 there, so it's 1 and 7, which makes that 1 and 7. This can't be 2 because it shares an edge with the 1, so this is 8 and 2, which means this can't be 8, so that's 2 and 8, which means this can't be 8, so it's 2 and 8. 2 cannot share an edge with the 1, so again, that's 7 and 1, which makes this 1 and 7, which makes this 1 and 7. 2 cannot share an edge with the 3, so that makes this 6 and 3, which makes this 3 and 6, which makes this 3 and 6. And that's how you solve it. Very cool, actually. I wasn't expecting it to function that way, but it flowed very well throughout. So it was a very interesting scenario with the non-consecutives and the black crop key dots. I didn't even check if the 1 to 2 ratios were... Well, the 1 and 2s obviously can't be next to each other, so that should be satisfied for that. And I don't know, I didn't check if all black dots were given. Actually, I guess I don't think you really needed that, actually, as a restriction, I believe. I think I solved it without using that negative constraint at all. So I don't know if that was necessary, but anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.